Hello, so let us look at number 5 together. Number 5 from year 2011, Form B. So I want you to read the question first here. B of t represents the position, and V of t represents the band's velocity. Now, A. Can we approximate band's acceleration at t equals 5? Acceleration when t equals 5 is basically derivative b prime of 5. Now this can be approximated by using the mean value theorem concept. B of t, b of 10 minus b of 0 divided by 10 minus 0, which now is equal to here 136 minus 100 over 10, which is equal to 3.6. And then in this case it will be meters per second. Now let's look at part B. What is the meaning of this? You see, velocity, if we integrate the velocity, it would have been displacement. But since we are looking at the absolute value, we are no longer looking at vector quantity but scalar quantity, which is basically means speed, which is the scalar quantity. That means integration of 0 to 60, velocity of v of t dt is simply talking about distance traveled from t equals 0 to t equals 60. Alright, that's basically what it is. Number C. 40 through 60. Must there be a time t when band's velocity is 2 meters per second? You see, since this is a twice differentiable function, even though when t was equal to 40, the velocity was 2.5 and then 4.6, we don't know actually what's happening. But what we have to do is, using the mean value theorem due to the differentiability, here f of c must be equal to b of 60 minus b of 40 all over 60 minus 40. Now denominator is equal to 20. That's rather simple. B of 60 was equal to 49 minus 9, which is equal to 2. So therefore there must be value c. Between 60 and 40, the velocity has to be equal to 2. So by mean value theorem, we agree with the statement. Alright, let's look at part D. A light is directly above the western end of the track. Bend rise so that at time t the distance L of t is the distance here between band and then the light satisfies this condition. At what rate is the distance between band and the light, meaning the L, changing at time t equals 40? So here we are looking at L prime of 40. Now, since L of t squared is equal to 12 squared plus b of t squared, one thing which we get to realize is this: when we take the derivative against time, then we have 2 L of t times L prime of t. And this portion, middle portion, becomes 0. We have 2 b of t times b prime of t. Now 2 and 2 cancels out, so essentially those two has to be equal to each other. When? It is when t equals 40. So let's try to look into this one. Then here we have L of 40 times L prime of 40, which we like to calculate, which is equal to B of 40 times B prime of 40. Now we realize that we need to calculate a couple of values here. What is B prime of 40 and what is L of 40? You see, when time was equal to 40, B was equal to 9. So here we have L of 40 square will be equal to 12 square plus 9 square. Then you will realize that this must be equal to 225, which makes L of 40 equal to 15. Alright, that's one way for us to figure out L of 40. Then what is B of 40? B of 40, we realize it to be 9. That's good. How about B prime of 40? B prime of 40 is velocity, which is equal to 2.5. So I think we have everything ready. So we have, if you were to rewrite this one, we get 15 times L prime of 40 is equal to 9 times 2.5. Now, then obviously we can have L prime of 40 is equal to 9 times 2.5 over 15. Now 2.5 and 15 can cancel out, becomes 6, which is equal to 1.5. So L prime of 40 is equal to the value which we just calculated. So therefore it is 1.5. What is the unit? Unit is meters per second. Alright, that's it. I'll see you later. Bye-bye.